Okay, 8BYP with another network video to explain the failure in the previous one. In the previous one, I'm very, very certain that loss resistances in this capacitor caused a serious mismatch. That's a pi network topology. Parallel LC circuits nearing resonance have a huge increase in impedance. RL and RC in parallel have impedance that goes down. So I calculated, and this is why being able to calculate this network is so important. It is not enough just to be able to plug numbers in formulas and get values. That's just about useless. We've got to know what's happening in the circuit. And this, unfortunately, is what engineers don't learn. It's learned by experience. But this node was, I think, 34 plus 20 something, which is a significant reduction from that. And so some few number of ones or tens of ohms here makes a big difference in that context. In the T network, 50 is in series with a reactance, and the impedance goes up because it's a series network. That is combined with that, R plus X, changed to an admittance. That's made an admittance, and this was the example I did in the two previous videos. So from here, every step over here is a step up in impedance. Then this goes over to a reactance that cancels, so to speak, the residual reactance in this node. Here, there's an immediate step down in impedance, which is not what we want. Nullify some reactance. And then the step up is over here at the input. That's not the correct topology, and for that very reason. Another thing to notice, there are some combinations of input-output resistance, frequency, component values that are just not workable. If you look in Radio Engineer's Handbook, this is all calculated based on phase angle, which is an assumption. Anything from 10 to 170 degrees. But certain values, for example, put these components very close to resonance. So a little bit of error in that network where these are close to resonance will really screw up the output. That's kind of a similar sort of problem with having that stray resistance here. These two aren't so critical because it's low impedance. But if this is tending to go towards resonance, which is where that's where the step up in resistance is, then if these reactances are chosen too close together, this circuit will be very critical. So it's necessary to do what ifs, several calculations, and make some difference in these two reactances so that circuit isn't quite so touchy. So this goes to explain why having some theory isn't good enough. This is why going through EE school and being inundated with math that doesn't mean anything is not good enough. We got to know how to do both. And there's nobody in any school I know of that teaches all of this. And unfortunately, we come out of engineering school having a head full of math and lots of book knowledge, but really no idea what to do with any of it. So, hope it's been helpful. KBYP did it.